All right, this is Simon Fairquell, the head. Are you the project manager on Docker Desktop on WSL?
No, no, I'm a software developer
Okay.
at Docker. Yeah, so yeah, my name is Simon Fairquell. I'm based in Paris at Docker. I'm a software engineer working on Docker Desktop and mainly nowadays on WSL integration. You can follow me on Twitter. My tag is sfairquell. And yeah, and today we are going to obviously talk about Docker Desktop and WSL2 integration. So we'll start with a bit of history, then dig a little bit into Docker Desktop architecture and understand how we design the WSL integration and why also we designed it this way. And then we'll do a bunch of deep dive demos, mainly understanding the startup sequence, understanding how cross-distro interop works, and a little bit about VPNKit bridge, which is the stuff that allows us to expose Windows service to the WSL2 environment and vice versa. So a little bit of history. I won't do the complete WSL history as Aidan has already done that as an introduction. But just about WSL1, we tried very early and quite often during the WSL1 timeframe to run Docker on it. And we were hit by major blockers, mainly because of the nature of the emulated kernel and the fact that Windows and Linux are quite different beasts. So when you run something as low level as Docker or Containerd or Runc, you actually depend on very specific behavior from the Linux kernel, and those behaviors were not fully implemented with WSL1, and for good reasons. So we felt that integrating with WSL1, but when WSL2 was announced in May last year, we were really interested in it because of the full Linux kernel compatibility and so the capability to run Docker with so much I/O improvements, etc. And there is a fun fact about those time frame because back in the day we told Craig and the WSL team that we were really wanting to do something with WSL2 and create a Docker Desktop-like experience at that time. And at that time, there was no way for them to ship an installable version of WSL2. So what they did was that they sent us a laptop, and as we are based in France, we actually got a laptop in another live event. It was at KubeCon in Barcelona. It was kind of a fun fact, like being just meeting some folk from Microsoft who told me, "Hey, are you Simon? Oh, here's your laptop." So that was really cool. So a few months after, we introduced the WSL tech preview for Docker Desktop. So what it was just a strong signal about our commitment to leverage WSL2 for our new experiences. It was kind of a quick proof of concept. It was not supposed to be a long-term maintained project, and actually it's not maintained anymore. But the idea was to introduce the concept of Linux workspaces with Docker Desktop, and so for that we did this little proof of concept that runs side by side with the legacy Docker Desktop thing. So after that we worked a lot about our new WSL2 backend, and what the new WSL2 backend is actually is a re-implementation of our Hyper-V based backend with the same exact interface, and that so we implement the same features. And so once we were ready to ship that as part of Docker Desktop, when you enable the WSL2 backend in Docker Desktop now, it just replaces entirely our Hyper-V backend. And so there is no more Hyper-V VM involved there. And recently, earlier this year, we added support for Windows Home. So it's on the Edge channel of Docker Desktop for now. And it allows us to target new users, obviously, and we also are preparing for the WSL2 GA later this year. So about this WSL2 backend and about how we designed it. So I wanted to show you a little, or a kind of a big Docker Desktop architecture diagram that predates the WSL2 backend. And it's not for explaining how everything works. It's just for you to understand the complexity of the program. We have so many moving parts, things talking to the hypervisor, things to proxify the Docker API, things to handle bind mounts, handle port forwarding, etc., etc. There are many things, and we also support both Mac and Windows, so we try to share as much code as possible. So we also have many different languages to deal with in the project, mainly Golang, C#, Swift, and even a bunch of C++ and OCaml. So yeah, that's a big project with many moving parts. And when we introduce a new feature, we really want to not overcomplexify things and try to reuse a maximum of existing stuff. So to dig a little bit inside the backend part of the Docker Desktop architecture, there is a simplified diagram about how we run the actual Docker daemon. So the Docker daemon runs inside a Linux VM, or before WSL2, it ran inside a Linux VM on top of Hyper-V. So we had our LinuxKit distro. So LinuxKit is a project that we created to be able to create custom Linux distros, and it's based on containerd, and so you can aggregate a bunch of services together and have a special purpose Linux distro out of that. It's an open source project now, so you can just look for it, and yeah, and it covers many more scenarios than just Docker Desktop now. So this LinuxKit distro, it ships with its own Linux kernel. It runs a bunch of services, like our lifecycle server, which is responsible for starting the Docker daemon on demand. It's also capable of running Kubernetes and things like that. There is also a diagnostic service, our networking service, VPNKit, and many more that I didn't show there. To assemble this, at runtime, to assemble this distro, we create an Hyper-V virtual machine, and we plug it a bunch of ISO files and VHD. So this Docker Desktop ISO file is actually the main LinuxKit distro, and we inject what we call a version pack, which is basically just the Docker D and Kubernetes binaries. And we also lay out on top of that your VHD, that is actually mounted in a directory inside the VM. So our distro is basically read-only, and we just have this VHD part that we mount in a known place inside the VM. So when we have to handle updates, we just have to swap the ISO files and keep the VHD, and we can keep the migrate your data just by adding some logic inside our VM, and there is no apt update or things like that. Everything is pre-baked in those ISO files. To expose those services to the Windows world, we also have a little process that we call VPNKit bridge. So it basically exposes Unix sockets as named pipes on Windows, and it's capable also to do the contrary, like exposing Windows named pipes as Unix sockets within the LinuxKit distro. So this is how we traditionally build Docker Desktop. This is the design of our Hyper-V backend. And so when we designed the WSL integration, we had a few challenges to tackle. First one is how to maximize code sharing with a Mac and Hyper-V. And by code sharing, I mean trying to have a single implementation of the lifecycle server API, of the diagnostics, and as well as a single code path for updating from one version to the other. That's very important for us because of maintenance cost. We are a small team, and it's a free product, so we really want to keep things as simple as we can. Second, we wanted to keep all the existing Docker Desktop features with WSL2. So we wanted to have support for Kubernetes, for our way to sync the trusted certificate authority between the Windows host and the Linux VM. And also we wanted to keep the same network capabilities. Something that we support is not blocking firewall. So that's because we actually run our own networking stack, and we make every network calls from that comes from the VM. We make it appear to firewalls like coming from the Windows host itself. So if your firewall is blocking NAT traversal, it shouldn't block traffic coming from Docker with Docker Desktop. Also, something that we wanted, and that is really important to us, is to have complete network isolation between your user distro and the Docker Desktop environment. And that's really important because if you look at how WSL works in terms of distro isolation, if you run two different distros, you can see that they get the same IP address, they get the same network interface, and that's because they all run in the same network namespace. And when you are doing things like IP tables, rules, and things like that, and that's something that Docker networking does a lot. You really don't want to run in the same network as many things that you don't control. And especially with our first experiments, what we try to do, for example, is to run the Docker daemon in two different distros at the same time, and things didn't get well at all. So from this big picture about the existing architecture and our challenges that we had, when we designed the WSL integration, we realized that LinuxKit distros can actually be run as containers. That's actually how we test LinuxKit distros traditionally. And what if we could create some kind of container in WSL2 that could run a LinuxKit distro? And I spent maybe 4 or 5 days creating the first prototype of our bootstrapper, which is just its role is just to create this kind of container. And actually, when we plugged a simple LinuxKit distro, it just worked. And there has been very few, oh my God, everything is working, and I didn't expect that. There has not been so many occasions like that in my career. And yeah, it was kind of a fantastic experience as a developer. So if we take this Hyper-V backend architecture, what we did for WSL integration is that we took the same existing pieces, like the exact same lifecycle server, diagnostics tools, VPNKit, etc. We even take the same version pack ISOs files, and we just created a LinuxKit base distro that doesn't ship with its own kernel. And so we can rely on WSL2 utility VM kernel. So this LinuxKit environment, so it's not a full VM anymore. It's just a container running within what we call the bootstrapping distro. And the bootstrapping distro role is just to create a Linux namespace and to run this LinuxKit environment. And so this LinuxKit container is isolated in terms of namespace, PID, mounts, etc. So it believes it's running just like a VM, but actually it's more a container. Very few difference though, because on WSL2 we couldn't plug our own VHD inside the utility VM. So what we did was we created another data store distro that we just use to store data and being able to swap the bootstrapping distro when we do an update. We also added, we kept the VPNKit bridge thing for exposing name pipes and things like that, but we also added another kind of proxy that I will talk a little bit more in a few minutes to expose things to other user distros like Ubuntu, Penguin, etc. So time for a demo about the startup sequence. So for that, I will get to Visual Studio first. And this is a real Docker desktop code. And it's just some small part of the Docker desktop code. And we'll see a little bit what happens. So when we start the WSL backend, we start by cleaning things up, and then we start provisioning the WSL environment. And what it does is that it's actually creating the WSL distro that we need. And yeah, complete, maybe. Okay. And so when it's done, I should have in my WSL environment, we should see this Docker desktop and Docker desktop data and distros lying there. If I go to Docker desktop, let me go to the root and I do ps3-b. For now, there is nothing running. So after having provisioning that, what we'll do is that we will do another cleanup phase here, but interesting part is there. This keep alive process, which actually wakes up the data distro, and that will create bindments so that we can use the data stored in this distro from within the Docker desktop main distro. So let me see if things are there. So if I do a cat /proc self muntinfo, we see that there have been two things coming from Docker desktop data, which is this ISO cache thing and version pack data thing. And they are exposed in a special directory within /mnt, and I will talk a little bit about that later. But if we look at this guy, for example, version pack data community, you'll see that here is a Docker data folder. There is also a directory for storing Kubernetes persistent volumes and things like that, storing the kubelet configuration, etc., etc. So after that, we'll create some configuration that will pass to the bootstrapping process. Because for now, if I do a PS3, there is still no container running, and so what we do there in this prepare configuration thing is that we actually prepare a few paths, like the path to the Docker desktop ISOs and a little config file. If we look at this config file, actually it's something that the same config file that we use for Hyper-V, and if I open it, we'll see things like the public keys of all the trusted certificates that you trust on Windows, so that we can populate the trusted CA store within our distro. And then let me start this. So we pass this config to the bootstrapper, and hopefully if I do PS3. Yeah. So, and now we can see that we have called this WSL, Docker Desktop has called this WSL bootstrap executable. And this WSL bootstrap executable has called unshare. And unshare is a Linux utility that we use to create a namespace. And within it, you can see an init process. From the perspective of the root namespace, it has PID 42, but we'll see a little later that it has PID 1 within the container. And we can see that containerd within the LinuxKit environment has started a few services. I get a little deeper after that. Also, let me start a little bit more things there. Yeah, so I started a little more things, and you can see that I've started. I don't know where it was, but yes, VPNKit bridge start WSL. So this thing has started the VPNKit bridge process, and what it does is that it will actually populate this run host services thing, which is actually these are Unix sockets that allows LinuxKit environment to talk to the services running on the Windows side, and it will also get everything that is in get services there, which is actually the services running within the LinuxKit environment, and it will expose them as named pipe to the Windows world. So now, you can see that within the guest services, there is not yet a Docker socket. That's because we actually have not started this yet. So we go to Docker service start, and I can actually let the debugger away. And now, if I list my guest services, I have this docker.sock, my Docker Unix socket listening there. So how the bootstrapping, the WSL bootstrap process did create this container. So first things that it did is that it created the root file system of this container, and actually you can see that it has it's /bin/tmp/var, etc., etc. And after creating this layout, it did a few bind mounts. It mounted the ISO files. It mounted things from pretty much everywhere, and so this will be the root file system of everything running under this init process. So although something that I'd like to show you, if I do an ifconfig within Docker Desktop distro, you can see that I have this IP. If I go to my Ubuntu distro, I get the same one, and actually it's the same, the exact same network interface. But let us now enter the namespace of this process. So for this, I will use nsenter, and I will target PID 42. So within this namespace, we have a different host name. We have this root directory that I showed you before. And if I do an ifconfig, you can see that we have different interfaces. We have interfaces for Docker networks that I created before, and the ETH0 has not the same IP. Actually, it's if I show you this thing, you can see that one of the services there that has been run by containerd is VPNKit tap vsoc, and actually it's the network it's the service that creates the virtual network interface that talks to the VPNKit backend on Windows to handle things like NAT blocking firewalls. So other thing I want to show you is that we actually mount a bunch of things within this container. So obviously we have the guest services that are there as well. We have the host services as well, and we also have we also mount the 9p Windows shares within this environment, so that we can leverage WSL 9p access. And let me just have a look at my notes because there are so many things I want to show you. And now, yeah, I can also move a little further. I and my screen, and you can see that there is this Dockerd process running within the LinuxKit environment. So let us go there, and this one has also its own root file system. It's not exactly the same, and we can have a look at how the /var/lib is actually populated in this container. So /proc self Ubuntu and little grep because there are so many things there. var/lib. And as you can see, we have actually mounted the version pack data directory from the Docker Desktop data distro. We have actually mounted it there. So everything that we store in var/lib is actually stored in this data distro. So when we update the bootstrapping distro for whatever reason, we don't lose the data. And actually, it's exactly what we do with the VHD on Hyper-V. Although if I do a Docker info there, I access the same Docker daemon as if I go to PowerShell and I do a Docker info. So now we have started Docker Desktop, and I showed you a little bit how we mount things within it. We mount ISO files, we mount the /mnt/c share from that WSL mounts for us. And now I will focus a little bit more about using WSL from a user distro. And particularly, I want to show you how we handle bind months, which is kind of a complicated topic, but it's also one of the most interesting features of Docker Desktop with WSL. So here I am on Ubuntu, and I'd like to show you something first. So I will cut my Muntinfo there as well. And if something that Microsoft added maybe just for us is this /mnt/WSL thing. /mnt/WSL, it's a tempfs that is actually mounted in all your WSL distro, and that allows you to share things between different distros. So, for example, if I do something like mkdir, or yeah, sudo kdir, oh, I don't think I need sudo. mnt WSL demo. I can go to another distro like Penguin, for example, and if I do ls-mnt WSL, this demo directory that I just created is there. And if you look at the Muntinfo, you can see this shared thing. It just says that this month has been bind month has been mounted in shared propagation modes. That means that if I mount anything within this shared directory, the mount will be propagated across all the mount points. So what it means is that basically from this Penguin distro, I can do something like sudo mount bind pretty much anything. Let's bind / for example, into this mnt WSL demo directory. And if I go to mnt, oh, I'm not in the correct one. If I look from Ubuntu, what is in there? So you can see that it's the root of my Penguin Linux distro, but I just mounted there, and I give access to pretty much anyone to it. It's not a very good thing to do, but that's something that we can leverage to share things across distro. And if you look at things that we share with any distro, so there are some interesting things. In Docker Desktop, you can see that there is this CLI tools, which is actually populated with Docker CLI, kubectl, etc. But the more interesting thing is this shared sockets. And you can see this guest services and host services thing. And in this get services thing, we get our Docker socket. And so we could have created scripts so that you can connect directly to this socket, but the problem is that this file has not a correct permission, so that it requires you to do a sudo to connect to it. And also, if I connect to it and I do a bind month, actually all month sources will be from the perspective of our WSL distro and from the LinuxKit environment inside our WSL distro. So the path that you express within Ubuntu wouldn't be translated correctly to this world. So what we added there is that we added what we call an API proxy. And so if I do a Docker info there from Ubuntu, you can see that I connect to the same daemon, but actually I connect through a proxy. And if I do ps aux, you can see there that it's running there. This Docker desktop proxy thing. It's actually the goal of this proxy is to expose the Docker desktop daemon at the default path with the correct permissions, and to handle bindments correctly. So if I do something like docker run -rm it, oops, and that I want to bind mount my home directory inside a container, I totally can. And if I do an assignment there, you can see that I get access to my Ubuntu home directory. So that's a cool thing. So how does it work? The way that we do that, I think it's best explained if I open the second terminal there. Yeah, let me use my Ubuntu environment there. So if I do cat/proc self mount.info, and I will grep mntwsl. Okay, what you can see there is that there is a new mount there that actually take my home directory and put it inside my /mnt/wsl, and it creates that with a certain path. And that's actually what the API proxy does. What it does is that it intercepts every container creation, and it rewrites bindments after having creating a shared mount point. And if I go a little deeper and I do a docker inspect on this container, you'll see that the mount, the bindment that I created before, it has been actually rewritten by the API proxy. And that's done transparently. I don't have anything to do. So that's one of the goal of the proxy. And the very good thing is when you do that is that every single distro on WSL runs on top of the same utility VM. They share the same kernel, so they share the same file system cache. And so it's really, really fast. These bindments are much faster than what we can do with Windows mounts. Okay, so now another thing that I'd like to show you is the fact that we also handle port forwarding in a very useful way when you're for a developer. So let me run Nginx container, and I will expose that on port 4242. Oops, I messed it up there. Okay, so my container listen on port 4242, and one thing that we really wanted with Docker Desktop is to allow you to just use -p and be able to use your container, use your browser, and be able to do that. And we took it a step further with Linux workspaces, because you can actually curl as well from this environment. So I can curl my localhost 4242. and I get the Nginx response. So the way it works is that we already have on the Windows side, we already have a component that listens for container creation and deletion events and handles the port forwarding for you. And it does that in collaboration with the service that runs inside the LinuxKit environment. And what we did is that for WSL is that every time that a port is exposed or unexposed, we broadcast the event to a service running in the WSL root network namespace as well. So actually, the process that descends on port 4242, it runs within the Docker desktop distro, but as we are running in the same network namespace, it's accessible from audio distros as well. So that's really handy for developer purposes. I think there's one last thing, yes, that I want to show you about Linux workspaces. So let's go to Docker desktop settings, and I will enable Kubernetes support. It might take a bit of time. And yeah, let me go to the Windows side and do kubectl get all. Okay, I have an answer from Kubernetes. So one thing with the Kubernetes API is that it only works on TCP using HTTPS and mutual TLS. And something that we did for supporting Kubernetes is that we use the same port forwarding mechanism. And as we did broadcast all port forwarding instruction to the Linux environment, actually it means that as soon as we did that, we could do a kubectl get all from Linux as well. So it relies on the same fundamentals as container port forwarding. Also, something I'd like to highlight with our Kubernetes thing is that if I do a kubectl get nodes and get some JSON about that, you can see that my node has access to a bunch of images. And actually, the very cool thing as a developer when I use Docker Desktop to develop on Kubernetes is that we share the same image store between Kubernetes and Docker. So when I do a Docker build, I don't have to push my image to a registry to be able to use it within my local cluster. And that's really, really handy. And finally, something I'd like to do is to actually deploy some workloads. I will use Composant Kubernetes for that because it's faster. So Docker stack deploy. I should have a compose file there. Yeah. Okay, so it's deploying this compose file on my Kubernetes cluster using Docker Desktop, and let's see what it has deployed. So it has deployed a few things. First thing is it deployed a stateful set with a DB. That means that we handle persistent volumes with our Kubernetes deployments. And it has as well. It has created a bunch of deployments which are stateless, and it also has published a bunch of services, including a load balanced service. And the way we handle load balanced service with Docker Desktop is that we ship a load balancer implementation that just exposes on localhost. So this service that is exposed on port 80 I should be able to reach it from there. So there it is, and it talks to other Kubernetes services. And as we already had port forwarding for Docker services, we also handle Kubernetes load balance endpoint the same way. And so I can also curl localhost from there. Yeah, and it works. So the idea is that we handle a lot of complexity to make very simple scenario work for developers, like being able to spin a workload and do a curl. It seems like something very natural, but under the hood, there is quite a lot of complexity to make it happen. And the same thing for bind mounts. It feels like completely normal that you can just bind mount something from your WSL distro, but there is kind of a few intermediary steps to that happen there. The good thing about this design as well is that you can actually interact. I interacted with Docker from Ubuntu, but if I go to the settings there, in addition to my default WSL distro, I can also enable integration with Penguin, Fedora Remix, for example, and just hit apply, and now I can go to, oops, Penguin, and boom, I have Docker, and with the same bind mounts, port exposition things, etc. So that's pretty cool, I think. So that's it for the demo. And one last thing that I wanted to show you was actually how we implemented VPNKit bridge for WSL. So something I'd like to highlight is how WSL handles communication between Win32 process and the Linux world. And if I do something like WSLD Ubuntu, what WSL actually does is that it's actually spawn a process within the Linux environment, and somehow it passes through the stood in and stood out between the parent Win32 process, which is my PowerShell instance there, and the process running within Linux. And there's something that's something kind of interesting, because it makes it very easy to communicate back and forth from Win32 and Linux process. This piping of stood in, stood out. And so if by extension I want to use my the netcat utility. Netcat utility on Linux, it's a utility that allows you to connect to a socket. It can be a TCP socket, or it can be a Linux socket. So let's do that with varrun docker.sock. And it allows you to use stood in, stood out to actually write data to this socket and read data back. So let's craft an HTTP request by hand in my Ubuntu shell to this Docker socket. So this is the end of my headers, and voila, I get a message back. So what I had there is that I have PowerShell passing is stood in, stood out to a process, to the shell running in Ubuntu. And so the stood in, stood out of PowerShell has invoked, has written this NC thing, has written this HTTP message and get the response back. We can get a step further that and do that in a single call like WSL-d Ubuntu and directly execute NC with the same parameters. And maybe we'll get to, you'll get some insight to where I want to go there. So now it's a single command line from PowerShell. And it feels like PowerShell is issuing a command to a socket running within my Ubuntu environment. That feels a little bit magical, and that's actually how we implemented VPNKit bridge for the WSL backend. So VPNKit bridge, basically, we can it's a multiplexer that expose services from named pipe to Unix sockets and vice versa. And on Hyper-V, it uses Hyper-V sockets to communicate between the agent running on the host and the agent running on the VM. And on WSL, what we actually use is stud in, stud out. So let me show you how we do that. So here's the way we set up our multiplexer. So we are within the VPNKit bridge process. And if I'm on Windows, what I do is that I actually launch VPNKit bridge within the WSL distro. And then I get the stud-in pipe, the stud-in stream and stud-out stream. And I set up my multiplexer using this pair of reader-writer. So what it will do is that it will run the exact same process within WSL, and within WSL it will take this branch there, and it will set up the multiplexer using the current process stud-in, stud-out. And that's the way we handle all communications. And by all communications, I mean pretty much everything. Even the VPNKit virtual network interface, the way it talks to the backend on the Windows side is through this VPNKit bridge thing. And that's quite amazing that a simple stud-in, stud-out pair, it can actually scale to a way that I can saturate my fiber connection at the office with, bypassing all network packet through this single stud-in, stud-out pair. And I'm quite happy with this implementation. And the original idea came actually from Ben Ellis from Microsoft. And I'm really thankful for this idea. It was kind of crazy at first, and when we realized it worked and scaled correctly, it was kind of fun. So Aidan, I'm not sure about what my talk is supposed to finish because I have a few bonus things.
We're running a little early, but that's fine because we have some questions for you. Do you have time for questions?
I have some for questions, and I have time for additional demos as well.
Okay. Well, let's. The first question we got was: did the introduction of WSL2 make Docker desktop any less complex? You mentioned a lot of moving parts, but I think Aaron wanted to know: were you able to remove code as a result?
So the ultimate goal is to remove the whole Hyper-V related code base at some point, but we are not there yet because we run a project that we support quite for a long time, and if you look at our CI there, I want to show you here. At the top of this screen, you can see all the version of OSs that we support, and we go back to Windows 15 or 63. So I think it's the anniversary preview, like a build that dates from before WSL1 or something like that.
Right.
So yeah, we have to support those builds. Incrementally, we will drop support for older builds of Windows, and at that time we'll be able to completely drop Hyper-V support. But for now, it's just more code, and so that's why we wanted to design it in a way that we can share most of it with Hyper-V and Mac.
Okay. Let's see. The ability to build a this is questions from Sebastian. To build a Docker image that you don't have to push to a registry to be used in Kubernetes, that just for WSL2?
No, it also works on Hyper-V and Mac.
Okay, so it works on the Hyper-V
And actually,
version and that.
yes, actually there are already tools that take advantage of that. If you look at Scaffold, for example, it has a special mode, a special working mode if you are using Docker Desktop, and so
Okay.
it doesn't need a registry in this scenario.
Gotcha. Carlos asked if you could show us how you enable the distros via the GUI.
Yes, so it's just there within resources. And now we have this little checkbox, so we track whichever default WSL distro you are using, and by default it will be enabled for it. But you can also check other distros there.
Gotcha. All right. Stuart asked.
Oh, sorry.
One more. Do you plan to re-enable mounting WSL/distro/path volumes when doing Docker run from Windows?
It's really difficult because we could do that the easy way, like by mounting through the Windows mount point, so go through the 9p thing, but the performance wouldn't be good. So to do that in a correct way, we would have to actually ensure the proxy is running from the source in the source distro and connect to that and do the same kind of mount rewriting that we do from within the distro. And actually we talked about that and we figured that it was easier to educate our user that they could just from Windows do some things like WSL -d Ubuntu and Docker run there. And it's much simpler for us, and it has the same scriptability than if you could if you did that in your PowerShell script. Actually, you can run WSL-d Ubuntu Docker run something with a bindman there quite easily from a PowerShell script. And so we didn't see the value of doing that given the cost it has for us to develop that.
Gotcha. So we have about 10 minutes if you want to show us any more demos until we move to Nuno.
Yeah, so I start with I/O performance with bindmans. So for demonstrating that, the main reason why we want users to use Docker from within the Docker distro is month's performance. So, for example, there I have a WordPress development environment, and the way it works is that there is somewhere a compose file, and there is somewhere your source mounted inside a container. so that you can live edit and your development environment will actually update. So let me start with this guy. So from there, I'm from the Windows side, and if I do something like, I think it's npm run, so this will deploy the run the compose file after having some sanity checks and things like that. And just to check which part it's listened to, so and docker ps, and it seems to be this one, 88889. So we'll do some poor man performance testing there. So, oops. If I go to F12 and check at the network connection and just hit F5, you can see that the load time is around 1 second, which is not too bad, and that's because WordPress has not such a deep include graph, and I will talk about include graph and how it impacts I/O performance in Node and PHP applications, especially. But let me just stop that and give you an idea of the performance that you have with Linux workspaces. And let's go there. So I just got the exact same environment. There is no cheat there. WordPress develop and same npm run of /start. So this is the exact same layout, the same compose file, same containers, and just the bind months are leveraging the API proxy, and it's directly bind mounting files from the same distro. And yeah, so what you can see is that performance is 1 order of magnitude faster, and that's just because if you look at how PHP or other language like Node work, actually they read source files, and they need to know if their cache is actually up to date. And from a local file system, it's really easy for them to know that, because there are identify events. There is a kernel file system cache that works for them. But if you share files from Windows, you are actually using a remote file system, and with that you need to ask for every single file that is in your include graph. You have to ask if your cache is fresh, and that takes a lot of time, and that's what we see here. And with WordPress, it's not so bad, but things get exponentially worse when you have deeper include graphs. And we had clients that were actually not able to work with Docker Desktop before WSL, just because of that, because their project had such include graphs that every refresh will take tens of seconds to complete. So yeah, I don't know if I have time for another demo.
Well, I've got a couple more questions that have come in. Any plans for an ARM64 build of Docker Desktop?
That's something that we keep in mind. It's not planned now because we don't see that much demand for now. Okay. And we are actually using technical stacks that don't handle ARM64 for now. Like we still use full .NET framework, which only work on x86 and x64. And we plan to move to .NET Core at some point, but it's not done yet, and we need to do that first before evaluating ARM64.
For the load balancing part, we have a question. Do you recommend a third-party load balancer or any particular best practices?
For development purposes, just use the load balancer that we ship with Docker Desktop, that is configured by default. It just exposes everything on localhost, and that's for development purposes. It's just perfect. You don't really need really more.
Okay. And are you using a custom kernel at all with inside any of your containers?
No, we actually worked a lot with Microsoft early days on WSL2 to make sure that the kernel configuration was correct for running both Docker and Kubernetes. And so we now run with the built-in WSL2 kernel.
Well, we have about 5 minutes until we need to introduce Nuno. Do you have anything short?
Yes, I have something short. If you look at what is a WSL distro, I just have to do something first. There it is. Okay, so if you look at what is a WSL distro, it's basically just the user mode part of a Linux distro, and there is something that is very similar to that, and this is actually a Docker container. A Docker container is the same thing, user mode Linux distro, and we attach some metadata to it. So what if we could actually pull a Docker image and create a container from that. Oops. And extract it as a tarball, like Docker export Redis. Oh, I have to do something there. Docker export Redis to Redis demo.tar. So this command will take my container file system and create a tarball out of it. And what if I did a WSL import of that? Actually, I always need to to check that. So install location. Okay. So WSL import. Let us name that Redis. Install location. I think I created. Yeah, this Redis 2 should work. And the source file is my tarball there. And now, what if I could just go to this new guy? And do I have my Redis server? Yes, there it is. So in a few lines of code, I reused a container image, specially purposed to run Redis, and converted it in a WSL distro. And actually, it can use the same exact kind of file system layout, so it just works. And the fun thing is that as we are running within the same network namespace as over WSL distro, I can actually use that for running special purpose payloads directly on WSL and connect to them directly from my other distros. So that's kind of cool. And I think it's all for me.
Yep, that's great. Thank you, Simon. That was really in depth and really informative. And even I learned things there about how you're spinning up the distros and doing the interaction. We got to a lot of different questions. If there's more, I think you mentioned your Twitter. Is that the best way to reach you?
Yes, yes, that's the best way to reach me. Don't hesitate to reach on at Feroquel, and I will answer there. I will be also on the chat for just a few minutes.
Okay, great. Thank you so much, Simon, and thank you for working with us on the schedule and the rearranging we had to do.
Yeah, thank you a lot for the opportunity to talk there.